Assalamu alaikum wa rahmatullahi wa barakatuh. How are you doing, my dear student Prep 2? Today we are going to explain the second term in science. And we have 3 units. Unit 1, periodic motion. Unit 2, sound and light. Unit 3, reproduction and the continuity of species. And Unit 1 speaks about periodic motion, have 2 lessons, oscillatory motion and wave motion. You have learned before in Prep 1 that we have 2 types of motion, transitional motion and periodic motion. Okay, transitional motion from point to another point, from initial point to final point. But periodic motion, it is a motion which is regularly repeated in equal periods of time. Examples of periodic motion, we have oscillatory motion and wave motion. To know the concept of oscillatory motion, we have the following experiments. Okay, like a movement pendulum, and in this movement pendulum, the periodic motion made by oscillating body around its point of rest. Okay, around its point of rest. So we can state that the oscillatory motion, it is the motion of the oscillating body around its rest position, where the motion is repeated through equal intervals of time or through equal periods of time. Okay, so this is the definition of oscillatory motion. Again, the motion of oscillating body around its rest point, where the motion is repeated through equal period of time. The velocity of oscillating body reaches its maximum value when it passes the point of rest, and it decreases gradually as the body moves away. Okay, and the kinetic energy equal half mass times v square, and the kinetic energy is directly proportional with the mass of oscillating body and v square. تمام، نركز كويس جدا that the kinetic energy is directly proportional to the mass and v square, and the kinetic energy increases with the velocity of the oscillating body increases, and so on. Okay, an example of oscillating motion: pendulum, tuning fork, spring, stretched string, motion of swing. Okay, motion of swing. Exercise number 1. Put true below the figures that represent the example for oscillatory motion. Tuning fork, yes, it's an example of oscillatory motion. Stretched string, excellent, it's an example of oscillatory motion. Rotary bee, no, it's an example of periodic motion but not oscillatory motion. Why? Because the motion of rotary bee is considered as just periodic motion. It's repeated regularly at equal period of time, but it is not oscillatory motion because it is not repeated on the 2 sides of its rest position. We must have 2 sides around the rest position to be an oscillatory motion. Properties of oscillatory motion are expressed in terms of many concepts such as amplitudes, complete oscillation, periodic time, frequency. Okay, let's speak first about amplitude. Observe the motion of the pendulum in figure 8. It makes maximum displacement when it reaches the point B on the right side and also the point C on the left side. So what is the relation between the values of displacement AB and BC? Yes, they are equal each other. The displacement AB equal BA equal AC equal CA. Each of them is called amplitude. Okay, each of them is called amplitude. So the definition of amplitude, it is the maximum displacement achieved by an oscillating body away from its rest point. Again, the maximum displacement achieved by an oscillating body away from its point of rest, it's called amplitude, and it is measured in meter. So the measuring unit of amplitude is meter, and this is the maximum displacement. The second concept, complete oscillation. What is meant by complete oscillation? Look at this figure, please. When the ball of the pendulum moves from B to A to C, then back to A, and finally to B, from B to A to C and A, and finally to B. Okay? The pendulum is said to have a completed one oscillation. This complete oscillation can be expressed as follows: from B to A to C and A and then to B. Okay, so we can define it as it is the motion of an oscillating body when it passes by a fixed point on its path two successive times in the same direction. Okay, two successive times in the same direction. Again, it is the motion of an oscillating body when it passes by a fixed point on its path two successive times in the same direction. تمام، نركز ان هي في نفس الاتجاه. Exercise: how many amplitudes does a complete oscillation between points x and y in two graphs, curve 1 and curve 2? In curve 1 we have, let's count, 1, 2, 3. So we have 3 complete oscillation. And in curve 2, 1, 2, 3, 4, we have 4 complete oscillation. In which graph the amplitude is larger, 1 or 2? The amplitude of curve 1 is larger than the amplitude of curve B. Look at here and here. In curve 1 is larger than in curve 2. The third concept is periodic time. Periodic time, it is the time taken by an oscillating body to make one complete oscillation. The time taken by oscillating body to make one complete oscillation, and it is represented by T and can be determined by the following relation: periodic time T equal time per second over number of complete oscillation. So to know the periodic time, we must divide the time in second over number of complete oscillation. Exercise 3. What is the periodic time for the pendulum oscillating in figure 12? Here we have the time of one amplitude. To know the time of one complete oscillation, we must times the time of one amplitude times 4. Okay, so 0.5 times 4 equal to seconds. So the periodic time, which is the time taken by an oscillating body to make one complete oscillation, is 2 seconds. Concept number 4, frequency. Frequency is the number of complete oscillations made by an oscillating body in 1 second. Again, number of complete oscillations made by an oscillating body in 1 second. And frequency equal number of complete oscillations over time. So frequency, it is the reciprocal of periodic time, and frequency times periodic time equal 1. The measuring unit of frequency is hertz. Okay? Measuring unit of frequency is hertz. And kilohertz equal 1 times 1 power 3 hertz. Megahertz 1 times 1 power 6 hertz. Gigahertz equal 1 power 9 hertz. Okay? Exercise number 4. Calculate the periodic time and the frequency of an oscillating body that makes 300 complete oscillations in half minutes. Here, the time must be in seconds, equal half times 60. So it will be 30. Okay, it will be 30 seconds. And the time, or the periodic time, equal the time in seconds over number of complete oscillations. So it will be 30 over 300 equal 0.1 seconds. And the frequency equal 1 over t equal 1 over 0.1 equal 10 hertz. Okay, so the frequency equal 10 hertz. Our lesson summary: oscillating motion, their concepts, and graphical representation of oscillatory motion. Concept related to oscillatory motion: amplitude, complete oscillation, periodic time, frequency. Example of periodic motion, oscillatory motion, and wave motion. Complete oscillations. Frequency of an oscillating body equals the reciprocal of its periodic time. Please study hard and try to solve many problems. Ask if you need help. Thank you.